High-intensity discharge headlights, otherwise known as HID headlights, have their basic principle of operation dating back over 300 years. However, it wasn't until the 1990s that HID became a prominent form of lighting in the automotive industry. Sealed beam and halogen headlights are incandescent, meaning they use a filament that is heated up by electricity to produce light. HID headlights, on the other hand, are arc bulbs, like a neon sign, where electricity arcs between two electrodes inside the bulb. HIDs are more efficient than halogen bulbs, emitting more light with less energy. Hi, I'm Palmer. Let's take a closer look at how this type of lighting system works and why it is still a popular choice for OEMs on the modern vehicle. The HID headlight system comprises of the HID bulb, igniter, ballast, wiring and control system, such as the lighting ECU. Looking further into this system, the HID bulb consists of a base and a thin quartz tube with two electrodes. The tube contains xenon gas, mercury and metal halide. These are contained in a pea-sized envelope formed in the tube between the electrodes. The two electrodes are separated by a small gap of around 4 millimeters. When high voltage is applied to the electrodes, it excites the gases inside the bulb and forms an electric arc between the electrodes. The hot iodized gas produces a plasma discharge that generates an extremely intense bluish-white light. Voltage supplied to the HID system is usually routed through a relay and fused at the power distribution center, or via a lighting control ECU. The normal 12 volts DC from the vehicle's electrical system is stepped up and controlled by an igniter module and inverter called a ballast, which also converts the voltage to AC. The ballast, igniter and HID bulb can be integrated into a single component or wired as separate units depending on the packaging requirements of the application. The ballast adjusts the voltage and current frequency to operating requirements. The AC ballast frequency is usually in the 250 to 450 Hz range. The high voltage required to initiate the operation of HID bulbs is around 25,000 volts AC and is applied to the tungsten electrodes. The xenon gas inside the bulb is then ionized and creates an electrical path between the electrodes, which lowers the electrical resistance of the gap between the electrodes. As the temperature rises, metallic salts are vaporized and provide a stable arc, emitting a high density of light. Along with the temperature increase, there is also a pressure increase inside the bulb, which can be over 30 bar due to the heat of up to 850 degrees Celsius inside the bulb. The HID ballast controls the operation of the bulb, regulating the high voltage to create the electric arc of 25,000 volts AC down to 40 to 85 volts AC once the electric arc is operating at its potential. The ballast also controls the current to the HID bulb. The change in voltage is evident by the slight delay of maximum light output as the bulb operates from a cold start. The amp draw on the electrical system by HID bulbs is initially higher than that of conventional halogen bulbs at around 6.5 amps per bulb during startup. This is compared to about 4.2 amps for a halogen bulb. However, after a few seconds, the amp load drawn by each HID bulb will start to drop, and after 15 to 30 seconds, eventually stabilise to around 3.8 amps per bulb. This means a HID headlight system will place less load on the electrical system and alternator over a period of time. Because there is no brittle filament inside a xenon HID bulb to break or burn out, the bulbs typically last over 3 times longer than halogen bulbs. That is around 3,000 hours of use versus around 500 hours of continuous operation for halogen, which for a typical vehicle is equivalent to 5 to 10 years of normal driving. The power-up of HID bulbs happens in 3 phases. First comes the ignition of the bulb, when a high voltage pulse is used to produce a spark which ionizes the xenon gas, creating a tunnel of current between the tungsten electrodes. After this comes the initial phase, when the temperature in the bulb capsule rises rapidly. The metallic salts vaporize and the resistance between the electrodes reduces. In the last phase, the ballast comes into full function and automatically switches to continuous operation. This is when all metal salts are in a vapor phase, the arc of light has achieved a stable shape, and the luminous efficacy has attained its nominal value. Being supplied with stable electrical power by the ballast, the arc of light will not flicker. Headlight systems have traditionally used reflector-type lighting systems. However, HID style lights most commonly use a projection-type headlight system. This type of headlight often has a smaller front lens that produces a high-intensity forward beam. It uses a lens system rather than the traditional reflector system to project the light forward. Due to the increased amount of light the HID bulbs produce, they are not used in a quad headlight system as can be done with halogen headlights. Instead, they are typically used as the low beam light only and a halogen bulb for the high beam. Since the quad headlight system uses all 4 bulbs for high beam operation, using an HID bulb in this system would blind any oncoming drivers due to the excessive amount of light output. Also, it is not possible to reduce the light intensity of an HID by pulse width modulation of the current to the element. To overcome these issues and to still be able to use HID bulbs, OEMs have been using bi-xenon headlights. Bi-xenon refers to the use of a single bulb to provide both the high beam and low beam operation. The full light output is used to produce the high beam. Low beam is formed by either moving the xenon bulb within the lens or by moving a shutter between the bulb and the lens. Systems that use the shutter will have a motor within the headlight assembly which raises and lowers the shutter. The position of the shutter will dictate the amount of projected light that will be allowed to escape from the lens and its pattern. In some systems, a DC electric motor is used to change the position of the bulb. The bulb is physically raised in the reflector housing to produce the high beam output. In low beam mode, the bulb is lowered in the reflector housing. The amount of reflection dictates the light intensity and pattern. Using the same bulb for both low and high beam operation permits both modes to have the same light colour. This reduces any visual contrast when switching between modes and is less stressful to the eyes of the driver. Several precautions should be taken when working on HID systems. There is a risk of electrocution, burns, or shock from the high voltages they generate. If diagnosing the HID system, be very careful when working on the system when it is live. You should wear safety glasses, high voltage safety gloves, and safety boots. And you should ensure that the vehicle, engine compartment, and ground under the vehicle are dry. If changing out the bulb, make sure the headlights are turned off. The manufacturer may specify disconnecting the battery when replacing the bulb. If so, follow the manufacturer's instructions. Be mindful of the high operating temperatures of the HID bulb and ballast, as well as the high pressures of the HID bulb. This pressure creates a potential explosion hazard, so do not attempt to power an HID bulb outside of the headlight assembly to test it, or operate it near flammable gases or liquids. The bulb must be maintained in a horizontal position when it is on, otherwise it may overheat and fail. HID bulbs use various heavy metals in their construction, so it is always important to dispose of the bulbs in an environmentally friendly way. Avoid breaking bulbs, as there is also a risk of poisoning caused by inhalation or skin contact with heavy metal vapours and toxic salts. When handling HID bulbs, use the same precautions as conventional halogen bulbs. Do not touch the quartz bulb because the oils in your skin can cause the bulb to crack and fail almost immediately. Ensure you wear gloves or handle the bulb by the base only. Due to the nature of safety risks when diagnosing HID systems, there are some basic steps you can take to identify what issues you might be faced with. If the bulbs fail to illuminate, a diagnostic scan of the vehicle's onboard system should be considered, as many of the vehicles running this type of lighting system operate through an ECU. Referring to a vehicle wiring diagram, check the supply fuse for correct operation and then for battery voltage to the ballast module when the headlight is turned on. If there is no voltage or the voltage is less than 12 volts, Check the wiring and supply circuit for the correct condition. Swap a known good bulb from the other side of the vehicle that is working. If the bulb works, you know the bulb you removed has failed and needs to be replaced. If the known good bulb does not work, try swapping the known good igniter module and ballast. If the headlight now works, the problem was a bad igniter or ballast, not the bulb. Therefore, the fault requires only the ballast be replaced. If the bulb still does not work, you have a wiring system issue. Make sure replacement bulbs are properly installed and locked in before reconnecting the wiring and turning the headlights on. Accurate bulb placement is essential for proper beam focus and cooling. If a vehicle has a cracked or damaged headlight lens cover, the lens cover or headlight assembly should be replaced. Water leaks and/or dust may contaminate the HID bulb and cause it to fail. If a vehicle has collision damage and a HID headlight assembly is being replaced, carefully inspect the wiring before reconnecting the wiring or turning the headlights on. A short could damage the igniter ballast module. HIDs produce more light for a given level of power consumption than ordinary tungsten and halogen bulbs. Automotive HID bulbs are commonly called xenon headlights, though they are actually metal halide bulbs which contain xenon gas. The light from HID bulbs typically exhibits a whiter light when compared with the yellow-white colour of tungsten filament headlights. HID bulbs produce between 2800 and 3500 lumens from between 35 and 38 watts, whereas halogen filament headlight bulbs produce between 700 and 2100 lumens from between 40 and 72 watts at 12.8 volts. The HID bulb also lasts considerably longer, around 3000 hours compared to 300 to 500 hours for a halogen bulb. There are some disadvantages of using HID headlights in vehicles. Some countries mandate that HID bulbs may only be installed on vehicles with lens cleaning systems to reduce glare and automatic self-leveling systems to prevent dazzling oncoming traffic. These systems are usually absent on vehicles not originally equipped with HID bulbs, so if a halogen headlight is retrofitted with a HID bulb, light distribution will be produced with illegal levels of glare. Another disadvantage of HID headlights is that they are significantly more costly to produce, install, purchase and repair. However, some of this cost is offset by the longer lifespan of the HID bulbs relative to halogen bulbs. As it can be seen, HID bulbs have the ability to light our way more efficiently with higher light output than their halogen headlight counterpart. I'm Palmer, keep training and thanks for watching.